right, here we go. So we did this 2 weeks ago. I know it's been a minute, but you have 3 different pieces, and you got to. It wants you to write the equation, right?
Yeah.
So we don't have y, we don't have x, we have d, and we have x, t for x. Are y'all okay with that? Huh?
Yeah.
I thought it wanted the description.
The equation. Yeah. We're
We're
gonna do the equation first.
I know the story.
You do a story? What'd you write?
I said at the beginning of the walk, this person walked 3 meters in 2 seconds. Then she or he stopped walking for 5 seconds, but then continued and walked home in 1 meter in 2 seconds.
Very nice job. Very nice
Oh,
job.
that's what you're supposed to do.
No, I want you to write the equation. Let me rewrite that for next year. Thank you, dear. I'm sorry about
Yeah,
that.
'cause I was writing a story about this girl named Katie.
Yeah?
So we walked to the dog park.
Yeah?
And then she saw this cute dog, so she had to stop
Yeah.
at that time.
So she stopped and so right here she was stopping and petting the dog and playing with the dog.
Quick question.
Yeah. And then she went home.
Yeah, her mom called. She was in trouble.
Oh.
All right, going back to Bella's story.
Yeah.
Real quick. So it says she got to her destination in 3 seconds. Am I right?
2.
Or 2 seconds.
Which one?
The first time.
First one?
First going around.
She got there in 2 seconds, yeah.
Gotcha.
Yeah.
Then it says she got home. How long did you say?
She stayed in
She stayed
walk for
still.
5 seconds.
And then.
Yeah, because
Got
between
home.
2 and 7 is 5
In
seconds.
3 seconds.
And then she went back home. Because maybe see how they're starting back at the same points?
I thought she said like 3 seconds she walked to the dog park.
No.
But then she
She
got
said-
back in 1.2 seconds. I'm like,
She
what
said
was
that
the
she
space?
walked 3. She said that she walked 2 meters in 2 seconds.
Gotcha. Meters up.
Wait, did you say 3? Yeah, Bella, that should only be 2 because it started at 1, so it should only be 2. Yep, it's okay. All right, so let's talk about the equations. What's the slope for this first piece?
3 over 2. 1.
It's 1 over 1, right? Which is just 1. And what's the y-intercept?
1.
So you got 1x and then plus 1. Well, we've got to write the interval. What are the intervals that she walked from? What's the x? 0. And it goes to
2.
2. That's what Bella said. We went to, what'd she say? She walked for 2 seconds? Is that what she said? All right, then we've got a second piece where, what was her name, Katie? Is that what her name? Is that what you called her? Called her Katie? All right, so Katie saw the dog in this point right here. And when she saw the dog, she's flatlined, right? She's not moving. So how do I write that equation? Her heart did not stop. The graph
She saw the
flatlined.
dog and she was just like,
Oh, and then she stopped. Yeah. So what's the equation for that? When you get a horizontal line,
There's no slope.
Why?
there's no, well, there is a slope, but it's 0.
oh, never mind.
It's just 3. Very good. It does have a slope. It's just 0. All right. And then what are the seconds that she does that? 2 to 7, which is where Bella was telling us she stopped and talked. Because it's a solid line. And it's not really less than, because remember, if you rewrite this, this would be 0 greater than 0, or x greater than 0, and x less than 2. It's an and problem, they're shaded together. Okay. All right, last one.
It feels like that's been almost a week ago.
It has been a very long time since we did this. All right, now this one, we got to do this differently, because we don't know where the y-intercept is, okay? So what's the slope, first of all? Negative how much? Ooh, not negative 1, that hit right there. Negative 2 over 3, because you went left 3. All right, and if you don't know where it hits the x-axis, that's what we had to do parentheses. Just bringing back some memories. Okay? All right, so inside parentheses, let's go over this. Inside parentheses means that you move left or right, okay? So from the very first point, how far to the right did that move? 7. So you got an x and you got a 7. We're not going to put plus 7 because when it's inside, it's the opposite sign, and opposite would be minus. Y'all okay so far?
Yes.
Kind of, sort of? We're going to do this in class all day today, so don't worry. And then if it's outside, outside tells you it moved up and down. So how much up did that move? Well, right here. It moved from the origin, it moved up 3. And when it moves up and down, you keep the same sign. All right, so what's the interval that that's on? 7 to 10. Does it have an arrow? No, so it stops right there at 10, okay?
Why did we do 0 for the first one?
That was the interval that it started on.
No, it's
The X. X is 0, and the X is 2. Yeah. Are y'all okay? All right. Negative?
Like, with the 0 is less than equal to x plus a equals to 2.
That's the X values that it's between. So see this,
Gotcha.
that X value that starts here is 0.
So
That X value where it
it's
ends
two,
is 2. Yes, between.
Gotcha, for like the middle.
For the middle one, it's between 2 and 7, because that's where those
Okay,
pieces are.
That makes a lot more sense.
Does that make sense now?
Yeah, so why do we put x minus 7 in parentheses?
Because we didn't know where the y-intercept is. If we were to draw that up, we wouldn't know where the y-intercept is. So we've got to write it like that. But on the first one, we did know where the y-intercept was, so it's easy. All right, 14, last one. 14, you got Kimmy and you got Carla. Kimmy thinks that it's the table and the graph are the same line. Carla disagrees with it. Who's correct? Kimmy's correct?
Jimmy's correct.
All right. Why?
Because it has the, like, this got the same slope.
How you know it's got the same slope?
Because I counted the slope on one and then did change the wire.
Ooh, look at you go, girl. All right, right here. What's the slope for this one? Up to right 1. So slope is 2 over 1. Are y'all okay with that? That's the easy one? All right, and she did change in y over change in x for this table. So here's my y's. Change meant we were going to subtract. Here's my x's. It doesn't matter the order. The only thing that matters is you can put them in the same order. So if I started with -1, I have to start with 0. That's -2 over -1, which is +2. Very nice. All right, now you have to have two things to check that they're the same. It's not just slope. What else do we need to know about?
Is it the same?
Is it the same what? That is the rate of change, Bobby. Rate of change is slope.
Same point? Is that,
What point is the special point that I need? When you're writing an equation of a line, y-intercept, Abby, very good. So what's the y-intercept here? -1. And anytime you saw that word intercept, what number did you automatically think of? No, number. 0. What's the y-intercept here? -1. Very good. So Kimmy is correct because they have the same slope and y-intercept. Y'all okay?
That person in real life with the name
I did. She was my arch nemesis in high school. Yes. Only because she treated my best friend horribly. And I got mad because of that. So.
Kimmy.
I know. I was not mean at all.
You should.
I was positive.
Hey, Kimmy.
She just knew not to mess with me. So, I was never ugly, ever, ever, ever. I really was not, I promise. Because I told her not to mess with my best friend anymore. I did, I wasn't ugly, I just don't mess with my best friend anymore.
Do you still keep up with them?
Her, no, my best friend, yes. Alright, so we're on page 27, but before we get on page 27, we have to do a checkpoint real quick. And then, Katie, as soon as we get done with that checkpoint, you can go outside and take your quiz, okay? I've got, well, most of them are already back. But I do have the other ones on my hand back while y'all are doing this. Here you go, Clay. Yes, ma'am. We did because that other stuff Friday was very similar to what we were already working on. So we just kind of skipped around a little bit. That way we can keep the same stuff. Alright, checkpoints are open notes, but they are not open notes. Open notes, but they are not open notes. I've got some things to hand back to you while you're working, so. Alright, so we all need calculators, because if you do not have a graphing calculator, please go get one. If you don't have one, please go get one real quick. Alright, so we are going to look at just the second definition, just the second one. So you've got a parent function is the simplest of all of your graphs. Okay, we learned 5 parent functions 2 weeks ago on Math Workshop, and we still have some more we've got to learn before you leave. So let's look at the first one. Constant. What do you notice about this graph? It's what kind of a line? It's a horizontal line. There you go. Or it could be vertical, right? Horizontal or vertical line. All right, what's the difference between a constant function and an identity function? What's the difference? They're both straight lines.
One has a slope.
One is diagonal, which is a slope. So this has a slope. And when we talked about these 2 weeks ago, we didn't call these identities. We called them something else. Remember what they were called? Start with an L.
Linear.
Linear. Very good. Smile at Sebastian, please. All right, y'all good? Y'all okay? All right, and then last one. These are the only 3 that we're going to deal with. Is absolute value. What did absolute value look like? The bars, right?
But it made a V.
And it made a V. So graph makes a V. All right, and let's go over those other parent functions. We're not going to use the other parent functions right now, but let's go back over them so that we all know what we're doing. Does anybody remember one of them? Anybody remember what it looks like? A parabola. What was the equation of a parabola? Y equals... It is a U. It is a parabola. It is what exponent?
2.
Exponent of 2, so it's x squared. Very nice job, guys. That was called a parabola. There's only 2 of them that had special names.
And
Square root, yeah. What did that one look like?
It was upside down.
No, not upside down. Sideways. Yep. But you couldn't have the bottom piece. Why could you not have the bottom piece?
Because it just don't look like that.
Oh.
you can't have
Yeah,
negative.
you can't do that.
Because we can't square root negatives yet. We're getting there. That'll be second semester. All right, and there was one more. Rational function. Very good. That was 1 over x. Y'all are on it today. 'Cause you had, what did you say? Well, I didn't. I did not sleep very much. Y'all, when homecoming is over, I'm going to sleep like a baby. Until then, I'm a nervous wreck. Do you remember what it looked like?
It had like the. It was like.
It was weirdly, yeah, it had this little curvy piece like this, and then this curvy piece like that. Is this bringing back some memories?
What was
Okay.
that middle? Square root?
It's just square root, yeah. It doesn't have any kind of special name. It's just a square root. Alright, so all it wants you to do on 1, 2, and 3 is just identify, and that's our learning target, right? So look at learning target number 4 right here on the board. What's it say?
I can identify parent functions.
Alright, so that's all we're going to do. So the very first one, what kind of picture is that?
Absolute value.
Absolute value. So, what's that? Does that have any kind of special name? It's just absolute value.
Then you have the.
Alright, and this one's a what? Because it's just a horizontal or vertical line.
And then.
Okay, I want you to know both words. So I want you to write identity slash linear. I want you to know both words, okay? Because the ACT loves to put the word identity, but we use the word linear a lot in class. So I want you to know both. Are y'all okay? All right, that's all we have to do for that one. That's easy, right? The second one is the only one we did, and it's a parent function. We didn't do the first one. Okay, so if you have some different color highlighters or something, you might want to grab those real quick and keep them out for a second. We're going to use it for this, and we're going to use it for something else in a minute. Maybe about 3 or 4 different colors, or just alternate every other one in different colors. Oh, got a blue one. Ugh, I can't reach. Got this light purple one. You just need 2 of them. Just kind of alternate. Yeah. You really just need 2. You can just alternate colors. Yes. All right, let's go. We don't have a lot of time. Just 2. Let's go. All right, here we go. Look at the very first one. We've talked about this in Math Workshop today, and we talked about it 2 weeks ago, okay? I know it's been a minute because of the storms and everything. All right, look at where the H is. The H is on the inside, right? And when it's on the inside, we take the opposite sign. And where does it move? Left and right. Y'all okay so far? This is big for pre-cal. You're going to see this again, okay? All right, then take your different color. And let's look at the next ones. All right, so let's look at where those letters. Where's the K at? It's on the outside. And when it's on the outside, we're going to keep the same sign. And where do those move? Up and down. Still okay? All right. So then, the only thing you need to know about reflections, you can mark out the second one, because we're not going to do that one. That'll be in pre-cal.
That's a negative.
Where's that negative at? He's on the outside, right?
Yes.
So when the negative is on the outside, what does it tell you to do? Reflect where? Over the x-axis. That's important, okay? Because when you get to pre-cal, one's going to reflect over the x and one's going to reflect over the y. So they're going to build on it. Are y'all okay? All right. And then the only thing you need to know is this word right here, dilation. And what are we doing with the dilations? What are we doing right here? You know, it's the same thing.
Stretching, compress.
Okay, we'll talk about that in a minute. We'll talk about those words in a minute. I know that y'all are very visual, so that's what we're going to do with our calculators in a minute. We're going to graph them, and we're actually going to see what they do. Okay?
It's absolute value.
No, that just means that whatever A is, you're always going to make it positive. And if it's greater than 1, it's going to do that. If it's between 0 and 1, you're going to do that. Okay? All right. Don't worry about it right now. Trust me. You're visual. Momentum. All right. Oh, wait. Number 1's at the bottom. All right. All number 1 tells you to do is what first? Name the parent graph first. So what's the parent graph? Let's name it. Absolute value. And what does the equation look like?
It looks like the translation.
No, pretend like that's not there. What's the parent graph of absolute value?
Y equals
Absolute value of x. That's it, right? Y'all okay with that? All right. Then it says to describe. Describe means let's talk about it, okay? We're gonna do it right this time. So we're gonna describe the transformation. So this parent graphs always start where? At the origin, at 0. So from there, what? So this 4 is on the outside, right? When the number is on the outside, that tells you to move either up or down, and we're going to take the same sign. So before we even graph this, we know that this graph should move where? There you go. Now we're going to take our calculators. Now, I have these little printouts of these paper calculators for you to kind of highlight in different buttons that we push. Does anybody want one of these? All right, come up here real quick and grab one. There's 3 different ones on there, so you can kind of keep them for later, okay? Anybody else want one?
Sure, Mom.
Oh, here, look, take that.
Yeah.
Same as your calculator. I'm gonna go, there. All right, last call. Anybody else? We'll put one on Katie's desk just in case you want one. All right, so when Katie's watching this in a minute, we'll put one on your desk if you got one. All right, last call. Anybody? All right, here we go. All right, so you need your, if you got a paper calculator and a regular calculator, get them both ready to go. All right, so where do we go first? Y equals, yeah, we got to turn it on first, and then go to Y equals. Let me make this smaller so everybody can see what's going on. All right, now, do not get ahead of me, because then you're going to be lost, and you're not going to know how to go back to your screen, so stay with me, okay? Don't hit any buttons unless I tell you to hit buttons. Y'all okay? All right, here we go. So the very first thing that we're going to do is we're going to graph our parent function so that we can visually see where this graph is being translated or moved up and down or dilated. Okay, y'all good with that?
Yeah.
All right, so if you have your paper calculator, you might want to grab your highlighter or something so you can highlight these buttons. Okay, the very first button that we're going to hit, is we're going to hit this math button. So on your paper calculator, you might want to highlight the math button. Y'all okay? All right, if you've got a paper calculator, you might want to get a different color so that you can see, like you can make it different colors. Does that make sense to everybody? So get a different color so that way you can see we had to hit a different button. Get a different color so you can see you got to hit a different button. Are y'all okay so far? Everybody on the math button? All right. Then we have to go over to NUM, which stands for number. So we're going to hit the right arrow button. So if you've got your paper calculator in a different color, highlight that right arrow so that you can see what we did, okay? And what's the very first thing that pops up when you hit that right? There you go. All right, now hit enter, and it takes you back. Now, you should have one of 2 things. Either yours is updated software like mine. If you've got the new calculator, it looks like it actually puts in those absolute values.
Yeah.
If you have the older calculator, it will say ABS in a parentheses. You're all okay with that? All right. Now, if you have the paper calculator, you might want to write on your screen, on the paper screen, what we were doing. We were graphing what? What are we graphing?
X.
Absolute value of X, right? So you might want to write on your paper calculator, graphing absolute value, so that you know what you were doing. So the very first thing we want to do is we want to graph Y equals X. Do you remember where X was?
Yep.
Right next to the green button. Now, if you have a calculator like Melody, you're going to close your parentheses. If you have a calculator like me, you're going to hit the right arrow button. Do not hit graph. We are not done. Don't go ahead of me. You're all okay? All right, then hit the down arrow button because we want our calculator to graph the parent function and we want it to graph the transformation. So what's the transformation? +4. So we got to go to math, go over to number, hit enter. What's the only thing inside the absolute value?
X.
X. So you hit the X. Now, that 4 is not inside the absolute value. So you either have to hit the right arrow button or you have to close your parentheses. All right, so you either have to hit the right arrow button or close your parentheses and then hit +4. All right, and then hit graph. The very first one that graphs is the parent graph. The second one that graphs is the transformation.
Do you always want us? What, do you always want us to graph for like the original?
When we're describing, yes, because that way you can visually see what happens.
Because I want to go over my window for the pen because
They should be all the same. I just don't know. So, alright, you remember what they are? Minimums are negative 10. Maximums are positive 10. I was like, I think it's pretty true. Are y'all okay? Alright. So now you can visually see what happened. It graphed, but what happened to the pin? It moved up 4. Are y'all okay with that? Because it didn't move left or right because nothing was on the inside. Alright, let's flip over. We're on page 29. Now, here's what I want you to do. We're going to kind of skip around a little bit so that we can keep the same thing. Let's do number 3. Ready? We're going to skip number 2 for right now. We're going to go back to it. And we only have about 15 minutes, so we don't have long. Luke, we good, baby? You good? Okay. Bella, you good, baby? Alright, here we go. Number 3. Number 3. The very first thing it said to do was name the parent function. What's the parent function? Absolute values. There you go. No calculators. No calculators. No calculators. Calculators should be put down. Don't make me call you out. Calculators should be put down. Number 3. We're on number 3, so. Alright. Before we even graph, where does the 3 tell me that it moves? No, it's inside. It's moved. There you go. Positive 3 normally tells you to move right, and Abby is correct. We are going to move left 3. Is anybody lost about that? Do I need to go back over that? All right. When your number's inside, remember that sheet that we highlighted a minute ago?
Yes.
Numbers are inside. You move left and right, and you take the opposite sign. So positive 3 normally tells you you're going to move right 3. But if you take the opposite sign, that would be negative 3. Negative 3 tells you to move left 3. You okay with that? Because it's inside. Yep. All right. Y'all okay so far? All right. Go back to y equals. Don't clear the first one because I want my parent graph in there. Let's clear the second one. Don't be lazy. I know some of you know how to work technology. Don't be lazy. Let's go back over this. Where do we go first? Math. Over to number. Hit enter for absolute value. Now, x and 3 are both inside, so I'm going to hit x plus 3. Don't change the sign. The calculator will change the sign for you, okay? Do not change the sign. If you have the updated version, hit the right arrow button. If you have the older version, close the parentheses. And then we're going to hit graph. All right, the very first one is the parent graph. And our learning target said that we can describe and graph describe and graph transformations. So let's describe it. What happened to it? It moved to the left 3. Y'all okay?
Yes.
Anybody lost? Sebastian, are you okay with your calculator?
I'm great.
You sure?
I know. Pretty.
I know what it'll do. Are you okay though? I'm pretty sure I do. Are you okay?
Great.
Taylor, are you okay dear?
Hang on.
What? Where?
I just wanted to enter so that was
Alright, we're going to skip number 4 for just a minute, okay? And we're going to go to number 5. Let's talk about number 5. No calculators. No calculators. Phones up. Calculators up. Here we go. What does this guy do?
It makes it negative.
He does make it negative, but what's he do to the graph?
Reflects it over the x.
It makes
Beautiful. Reflects over the x-axis.
So it's on the absolute value part.
Yes, it is. I'm sorry. I got to start with that, shouldn't I?
Oh.
Thank you. It's an absolute value, which is y equals absolute value of x, and it reflects over the x-axis. Because it's a negative in the front.
Question.
Yes.
So when we're writing it,
Uh-huh.
so like when we're writing it, we have to change the sign to our calculator.
You only need to change the sign in your head. You don't change it on your paper.
Like what if you're asked?
So you change the sign in your head. but we're not changing any sign. All right, right here. What's this guy? If he's on the outside, so Luke, on the inside, we had to change the sign, right? Okay, but when they're on the outside,
You don't.
we don't. And it's going to move up and down. So what's the negative 2? Anybody? What's the negative 2 going to tell me to do? There you go. Moves down 2. Now let's grab our calculators. All right, don't clear the first one. Because if we clear the first one, we're not going to see where it moved to, right? So how do we do absolute values? Math. Yeah. And enter. Beautiful. All right, now, oh crap, I did.
What do you have to do?
Yeah, we do. I forgot about that. Sorry, hit clear. Sorry. All right, now look, you might want to make yourself a note. If you have a paper calculator, you might want to make yourself a note on that calculator. You ready? The only time you hit this negative right here at the bottom, the only time you hit that negative, if it's in the very, very front of the problem, okay? You might want to put a note like C number 5 on page 29. You might want to make yourself a note, C number 5 on page 29, okay? The only time you hit that negative, if it's in the very, very front. If you hit it in the wrong one, if you hit the subtract instead, it will give you an error. All right, so here we go.
Syntax error.
It will give you a syntax error,
What's syntax error?
meaning that you didn't hit the right button. The calculator doesn't understand what to do. All right, hit the negative button, then let's hit math. Sorry about that, guys. All right, then we hit X. All right, now, if you have the older calculator, you have to close the parentheses first before you hit subtract 2. Do you see the difference in the size? Do you see how the negative is very, very small in the front?
Yeah.
But the subtract is much larger in front of the 2? Okay, so make sure you hit subtract 2. Y'all okay? All right, and let's graph it. The very first one is your parent graph. It's the original. And now you can visually see
Whoa.
what happened to the graph.
Wow.
What happened to it?
It went down.
It went down 2, right, from the origin. It went down 2, and then it flipped over. Y'all okay?
Yes.
All right, here we go. So let's do, we are not going to do number 7. Let's finish out number 6, okay? Guys, I am going to teach you how to do the fraction button, but it is not today because it is much easier to still do it the same way than it is to do the fraction button, okay?
Multiply everything by 5.
No. All right, let's talk. You ready? Let's talk. What's the parent graph? Absolute value, which is y equals absolute value of x. Okay? It moves up 3 because of this guy. What else does it do? Don't say over. It moves right. You got to take the opposite sign. When it's inside, it's going to move right 1.
You don't have this, doesn't have a slope.
It does not have it. We don't treat that like a slope. Okay? What are we doing to this 1/5 and that absolute value? Are we adding? We are multiplying, right? And look back at that other page. When we are, somebody let Katie in. When we are multiplying, what was that word that we used? Look back at the other page. Dilation. So it dilated 1/5. Okay? Which means, and let's graph it and figure out what it means, okay? So go to your y equals, yep, and we do parentheses, 1 divided by 5, close your parentheses. All right, and then we got to do our absolute value, so we go to math, over to number, hit enter, and we're going to hit x, subtract 1. Do not hit the negative. Hit the subtract. All right, and then you either need to hit the right arrow button or you need to close your parentheses before you hit plus 3. All right, and then let's graph it.
So you're just
Do you see what happened? Oh, look at what happened. It compressed vertically, or we could say that it stretched. Which way? I like that word better. That's just big. But if you say compressed, it's the same thing. All right, so it went like this, and then it stretched out horizontally, right? Does that make sense to everybody?
Yeah.
Okay, so what can we say? Dilated by 1/5, which means it stretched horizontally, or Abby, you can say compressed. Yep, either one.
Negative fraction and it's
If it's a fraction, it's going to move it outward like that. And a fraction is a decimal value. If it's a whole number, it's going to move it this way. Yep. So it stretched horizontally. Are y'all okay?
Yes.
Okay. The only reason we are using the calculator is because we missed 2 days. You have to know these rules. Does that make sense to everybody for a pre-cal? All right. So we are not going to use our calculator first. We are going to do the rule first, and then we are going to check. It is not going to do you any harm right now, but when you get to pre-cal next year, it will do you harm if you do not know these rules. Are y'all okay? All right, so let's move to the next one. Here we go. Do not use your calculator. Oh, wait, we skipped. We went back. Yep, we need to go back and look at those. All right, let's look. Let's go back at 2 and 4. What's the parent graph for number 2? Y equals x, which is linear or identity. Make sure you know both, okay? That's y equals x. What's this guy going to do? Move down 5. There you go. All right, let's grab our handy dandy calculator now. And we can clear out both of them. Because our parent function is simply x. And then what is our transformation that we're going to describe and we're going to graph? X minus 5. X subtract 5. Are y'all okay?
Yeah.
All right, then hit graph. The very first one should be your parent graph, which goes through the origin. I have it set that way for y'all. I actually have it graphed slower than some of y'all do because you can see it. If it graphs too fast, y'all can't see what happened. Are y'all okay? The only thing it moved is moved down. It's got the same slope, same everything. It just moved down 5. Good to go? All right. Let's look at the next one. Number 4. What are you doing to this 4? Multiplying. So when we multiply something, what do we call it? A dilation. There you go. A dilation. Let's just put dilated. Dilated by 4. And the parent graph was an identity or linear, which is y equals x. All right, so let's grab our calculator. The very first one is y equals x. That's our parent graph. But then the second one we're going to plug in is y equals 4x. And then hit graph. All right, so there's your parent graph first. Wait for it. There it is. Y'all okay? All right. So what happened here? It stretched which way? Vertically. Because see how it was? It was here. And then it got moved up vertically. Are y'all okay? All right. So here we go. We're going to see which means...
Ms. Lightly,
Yes,
can you
ma'am.
ask people to the attendance window for just a minute, please?
Yes, ma'am.
Thank you.
Y'all okay?
Yeah.
Easy enough? All right. So now let's do some graphing. We only have 4 problems to do and we have 3 minutes. We got to hustle. All right. Here we go. Let's hustle. No calculators. No calculators. All right. It moves where? Left 3. There you go. Here, move left 3 and put us a dot. All right. Now let me show you this. Our parent graph is y equals absolute value of x, right? What's the very first number that we could plug in? Pick a number, any number that we could plug in that's really small. 1. Let's start with 1. What's the absolute value of 1? So remember, we go right 1, up 1. And let's do negative 1. We're just picking random numbers so that I can show you why we're graphing them this way. That's 1. So we're going to go left 1 for a negative 1. and up because we got a positive 1. So what did we do? We went out 1 and up 1. All right, let's do the next number. What's after 1?
2.
2. What's the absolute value of 2?
2.
So we're going to go right 2 and up 2. All right, so let's do negative 2. Negative 2 tells me I'm going to go left 2. But the absolute value of negative 2 is 2. So each time I'm going out how much and up how much?
Out and up.
Out and up 1, right? So it's just keep going. You're just going out 1, up 1. You don't have to write any of that stuff. I just did that to show you what's happening. We've got 3 more on the back. We're not done. Are y'all okay?
We do that arrows, right?
We do arrows, yes ma'am. Are y'all okay?
Finish with the closed line.
Yep. All right, here's your homework for tonight. You ready? Homework for tonight is 2 things. Flip over. Homework, don't move. Homework for tonight is to graph 2, 3, and 4. And then to use your calculator to make sure that you get the same answer on your calculator. Graph them by hand first. If you got a checkpoint, put your checkpoints in the tray. Y'all have a great day, and I will see you tomorrow.
Here's, you chose one, you didn't